Jimmy, what do you think about partitioning? When should someone think about partitioning a table versus not partitioning? Because partitioning comes with its own overhead of maintaining the partitions, right? So what are your recommendations there?
Right. So partitioning is a really popular topic. I've had people asking me about partitioning for decades now, right? They were like, when is Postgres going to support partitioning? And then it started supporting partitioning natively. And then they said, okay, so what do I do with it now? Do I need to partition? And that is a very good question. So many people think that partitioning will solve their performance issues, but there's only one kind of performance issue that I can think of that partitioning will solve, right? It's when you have an excessively large table with a key that lets you access specific areas of that table, right? It can be faster sometimes rather than having one huge index with that key and looking through the huge index. It can be faster sometimes to eliminate some parts of the table that you know you're not going to need. And this is what's called partition pruning. It's a thing that Postgres does when you send it a query that takes advantage of the partition key and the where clause. It knows which partitions to look at. So let's say if you have 100 partitions and you're asking for data that because of the key you specified can only be in one of the partitions, then Postgres will not examine the other 99 partitions. It will go straight to the correct partition and retrieve the data for you. Right? That's how partitioning can improve performance. But in most cases, you will get the same performance from an unpartitioned table as with a partition table. So why do it?
Yep.
And the answer, it was sort of a rhetorical question, right? The answer is for ease of maintenance. You did say that partitioning means that you have to maintain the partitions. Like if you have something that grows over time, a table that grows over time, you need to keep adding partitions as you get a new month or new year, let's say, or a new day. But it makes maintenance of the table so much easier. Let's say you want to get rid of some old data in a table that's 20 terabytes. Then you have to go and find the very old rows in a 20 terabyte table and delete who knows how many rows, thousands or millions of rows. And that delete operation is going to be slow, and it is going to slow down the usage of the table for other users on the system. Whereas if you have tables that are partitioned by time, you can just go in and drop the latest partition or archive it, copy it somewhere else, and drop it. Right? And that's an instant DDL that is over in seconds, milliseconds, sorry, as opposed to deleting millions of rows. You can just drop the partition that contains the millions of rows.
Yeah, you can detach the old partition. Yeah, I think those are the two use cases, right? Like one is the performance benefit in some cases, and purging old data. And how about the third use case? I mean, I've seen a table in one of my projects earlier. It was about 1.3 terabytes, and the vacuum was taking forever. So do you do partitioning in those cases?
I have seen a vacuum job that never finished. There was someone with a multi-terabyte table, and their vacuum had been running for a month, and it hadn't completed yet. Because, you know, vacuum doesn't just press on regardless. A vacuum needs to obtain locks and voluntarily gives them up so that other people can use the system. So you can get into a situation where the vacuum never gets a chance to run if you run a really busy system. And when you have a huge table, it's really plausible that the vacuum will never finish. So this is where partitioning can help you. because you can have many smaller vacuums that get a chance to complete. Because each table can be vacuumed individually or auto-vacuumed individually.
Yeah, there are parameters like vacuum cost limit, etc., and they will throttle the vacuum. I think partitioning a large table might definitely help in vacuuming problems.
Yeah.
And
Also think about how hot your data is, right? Let's say that you're most likely going to be interested in the most recent rows in this huge table. And why should you wait for vacuum to touch the very old rows as well if you're interested in vacuuming the table that is seeing the most activity, the most recent rows, right?
Yep. So having said that, how do you choose the partitioning mechanism, whether to partition by range, by hash, or list? What is the approach there?
Yeah, you really need to sit down and consider your options there. So hash partitioning is usually meant for things that you don't know how to divide them well. Like you have a whole lot of unique identifiers that don't make much sense. They're not in a range. Let's say you have UUIDs, right? UUIDs before UUID 7 cannot be ordered. And now we're fortunately getting UUID 7 in Postgres. It is in the pipeline. If not in Postgres 17, then we will see it soon afterwards. And that gives you the ability to order UUIDs. But when you have a whole lot of things that do not belong in a range of identifiers, let's say, then you can use hash partitioning to divide them into roughly equal partitions. So you can say, divide all of these rows into 4 tables, or 10 tables, or 1,000 tables. Range partitioning is more useful when you have a really clear picture of how you want to divide your data. Like the example we mentioned, partitioning by time. If you have a timestamp, then you can say, the data that belongs in this month goes in this partition, the data from last month goes into another partition. And that's generally range partitioning. You range by the date. And the third type is list partitioning, which is you define a list of values that you can use as the partitioning key, and different things go into different tables. That's the whole idea of partitioning. Different types of rows go into different partitions. And let's say you can have partitions of different processing status for a row. Let's say unprocessed rows go into this partition. When they're processed, they move into another partition, depending on the status, right? And so forth.
And how about partitioning key? I know cardinality is one of the important factors when you choose a partitioning key, and also you need to look at your queries. So what are some recommendations there in choosing a partitioning key?
Yeah, cardinality is really important, because let's say that you want to partition by status and you only have 2, right? If you have 2 kinds of status, then the only number of partitions you can have is 2. So it's not a very good partitioning key in that sense. But if you have dates, then you can create meaningful ranges from them. Or if you have geographical regions like cities, then you can create a table for each city. So there has to be enough selectivity in the key for you to allow you to have a meaningful number of partitions. Sorry, what was your second question?
One is cardinality, the other is you look at the queries, right? Like the where clause, when you
exactly
queries and choose the partitioning key.
Yeah, that plays a huge role, because if you're going to be retrieving rows based on, let's say, when the activity took place, then it makes sense to partition on the timestamp. But let's say if you are just retrieving rows based on their ID, then it wouldn't make sense to partition them by time. If time is not included in the where clause, then you wouldn't get any benefit, let's say, from partition pruning, because the identifiers could end up being in any of the partitions, and you would have to look through all of them.
Yeah, I mean, I've seen a case where people partition by range, and again, that partition, each partition, again, they partition by hash on some other column. So is that something useful in some cases, like to use both in conjunction?
Yeah, definitely. Sub-partitioning is, I think, really useful when you have lots of data. Let's say that you want to partition the data by month, but that doesn't give you enough granularity. Your partitions end up being too large for you to use. Again, then you can say, I can partition them by month and also by day at a second level. Or you can do something different and say, I will partition them by date, but also by location, which store the transaction happened in, right? And you can create a hash, or you can create a list of locations and say that these were in North America, these were in Europe, these were in Asia, and so on. And then have each month be partitioned into regions, or the other way around, depending on what makes sense for the kind of queries you're going to run.
Yeah, that's a very good idea. And now coming to converting a regular table to partition table, right? What are some challenges there when you have a critical production system and you want to do with minimal downtime? What are some suggestions there?
Right. So your options really are when you have to keep using that table while you're partitioning it, it's really hard to orchestrate this operation. So what you have to do is, first off, you cannot convert a table that is not partitioned to a partitioned table. So that's square one. This means that you have to copy the data into a table that is partitioned, right? So this means that you will incur overhead. And if your system is under heavy usage at that moment, then you will also have a copy of data happening in the background, right? So this is something you have to consider if it's a large table. So what are things you can do, right? You can choose less active segments of your data and start copying them into partitions. If you know, for example, that nobody's going to touch transactions from 10 years ago and that they're not changeable by your system, then you can just take those, put them in a partition, and then build the partitioned table block by block until you reach the very latest data, right? So that's one strategy. Obviously, if it's not that easy to divide your data and there needs to be access to all of the table at once, then you can set up triggers. So while you're copying the data into the new table, any updates that happen on the old table also get copied to the new table, right? So that's how you can keep them in sync. So that is basically what you have to do when you have one database at your disposal. But there are other options as well. With logical replication, for instance, nowadays, you can logically replicate partitioned tables, and also you can replicate into partitioned tables. So immediately you see an option here. You can set up a second database somewhere that is a logical copy of the other database. And the only difference is, instead of copying into a table, your huge table into a huge table in the logical replica, you can create a partitioned table in the logical replica and then copy into that. And it automatically gets partitioned as you're performing the data copy. And then once everything is in sync, you can just cut over to the other machine that the logical replica that has your partitioned tables. That is one way to do it.
That's an excellent idea. I think if you use logical replication, you can have one of the replica already partitioned, tested for some time in whatever way we can, and then cut over. Yeah. And how about your idea about having a shadow table and renaming all that in a single transaction? What do you think about that strategy?
Yes, sometimes the table is so large that even copying the data is not an option, right? So sometimes you're forced to do it on the same system. And in that case, you just create another table, copy the data into it. As we said, you implement triggers to make sure that the data is up to date on the second table that is partitioned. And then you start a transaction. And that's what's great about Postgres. It supports transactional DDL, which means that in one transaction, you can rename the old table to table underscore old, let's say, and the new table, rename it to what your table name used to be. And that will only take a very short time and a very short duration lock, and it will generally not affect the operation of your system, because that transaction will take very short time to execute. Now, there are things you have to consider as well, right? So you have to have indexes in place, and you have to have all the things you had associated with your old table now being associated with a new table. For instance, sequences, right? There's all these things that need to be in place for the table to be usable, but it is definitely doable.
So what are some limitations in Postgres partitioning as of now? Are there any limitations that people should be aware of?
In older Postgres versions, if you had too many partitions, and now you will ask, what is too many? A few hundred partitions was too many in the past. It just didn't scale well. When you had a lot of partitions, Postgres tended to slow down the queries. Now that's fixed. You can have thousands and dozens of thousands of partitions per table, and it doesn't really matter to Postgres anymore. Now, whether it's a good idea to have many thousands of tables in your schema, that is a different story, because you have to understand that the Postgres catalog is a database in itself, right? And you're burdening the catalog with too many things. If you have 270,000 tables, then those require 270,000 entries in the catalog for their columns, their attributes, their indexes, and so on.
And one more question people usually have, they have a large table, they have performance issues, and in their mind, they think partitioning could help, but they're not sure, right? Until they partition and test the application. So how should we address this scenario? I mean, just blindly partitioning a large table when you have performance issues is not a good idea unless we benchmark, load test, or whatever, right? So what are some approaches here?
Definitely. In any case, I would always recommend that if you have a system in production, you should have a staging system as well, where you can test things under similar workloads and with similar data sizes. Even if it's scaled down, right? You should be able to have a system that is functionally identical to your production system and that is able to cope with the same demands. So that is an option. You can try out partitioning on that system to see how it will respond. But generally speaking, you will not get a benefit from partitioning unless you have really thought it through. you need to understand why you are partitioning and what Postgres can give you that will help you, whether it's the ease of use that we mentioned with managing your data set, or partition pruning. And partition pruning is really dependent on which key you have chosen, which partitioning strategy you have chosen, and also how your queries are written, if they can take advantage of the partition key to perform partition pruning.
How about setting up logical replication like you mentioned earlier, and then testing on the logical replica, having partition data there, or replicating from the primary and testing on the logical replica that is only there for testing? Is that a idea that can be implemented?
Yeah, that's a viable option, of course. You just have to be aware that many organizations do not allow production data to be used in any sort of test systems. So you might have to perform some manipulation before the data ends up on a non-production system,
Okay,
like masking and anonymizing things.
Yep, totally agree. And how about managing these partitions, right? Like, do you leverage PGPartment extension, or what are some recommendations there? Because when you have a ton of partitions, managing them is a headache sometimes.
Yeah, so it can be as simple as organizing cron jobs that do your, like, scheduled tasks that do your partition creation for you or your partition management, if it's simple enough. PGPartment used to be very useful back when Postgres didn't have many partitioning facilities, right? It was basically your only option was to use that extension. Now that Postgres supports partitioning natively, it just gives you a set of features that you don't get in core Postgres, like automatic partition creation and so on. But you can also get those from commercial products based on Postgres.
Yeah,
I think Timescale performs automatic partition management. EDB's advanced server does it, and so on. So PGPartment, the problem with using an extension is that you need to, if you're not running Postgres on your own platform, then that extension might not be available on a platform that you move your data to. So let's say you take your data from on-prem and you move it to a cloud provider, and then you find out that the cloud provider doesn't allow you to install that extension. So
yeah.
I'm a fan of trying to do as many things as possible with core Postgres before you resort to using an extension. Because extensions also, you have to understand, they have their own life cycle. So you have to keep them up to date as well. And the life cycle of an extension is not the same as Postgres. So when Postgres 17 comes out, all of the extensions will have to be updated for Postgres 17, but there's no guarantee that they'll be ready in time for Postgres 17. We try to, but there's no guarantee.
I totally agree, man. Yeah, if you keep adding extensions again, tomorrow they may not maintain that extension, or when we upgrade, we might run into some issues. Unless it is really, really needed, I think it's better to minimize.
Yeah.
And like you said, I think PGPartment mostly is helpful when you create partitions. Otherwise, these days, it's not super duper helpful like it used to be previously. And one other question is about the timing, right? Let's say you have a 2 terabyte table and you decide to partition. We need to get approval from business and app teams for testing. How long that would usually take? Because it's a series of events, right? You need to test it in staging, application needs to test it. Like a 2 terabyte table from your experience, or a 5 terabyte table, how long the entire process would take until live?
I'm really glad you mentioned the organizational overheads of
Yeah.
performing something like this, because it's not just the data copy, right? You have to consider the data copy. So you need to test, actually, how long does it take me to move 2 terabytes of data over to the other data center or to the other database? Or to the logical replica, right? It might take months if you have a slow connection, who knows? So that's something you have to test definitely, but there are other considerations within your organization. If you like have to notify the development teams that the table is now going to be partitioned, or that the operation of the database is going to be degraded because of the overhead of the copy. These are all things you have to factor in and notify other people and get clearance to do them. I think the easiest one to answer for is how long it takes to copy the data over, because it's something you can easily test. If not on the production system, so that you don't have overhead, you can test it on a system that is similarly configured.
Yeah, and then the management overhead of approvals and testing with the partitioning, all that adds up, right?
Yeah.
About
So, sorry, just to follow up on that, if you present a valid business case for performing the partitioning, it's like if you know, if you say, I've tested it without partitioning and with partitioning, and it saves us time because of partition pruning, then anything that can be translated into a cost saving for your organization because you don't have to go to bigger servers, for instance, then that will play a role in getting your approval. So make sure that you're doing things for the right reasons and not simply for the elimination of technical debt. Make sure you present a valid case of what the benefits will be to whatever operation you're planning to perform.
Thanks, Jimmy. How about rollback strategy? Like, let's say it's a very critical system. When we try to partition, maybe we should have rollback strategy. Let's say we partition and make it live, and something doesn't work out as expected. We need to go back to our original layout, right? Did you experience something? What is your take on that?
I think the only viable way to do that is have logical replication going on. So you can logically replicate into the other system and start using it if you can switch over parts of your application, let's say to the new system, one at a time, then that is a strategy that you can use. But a full rollback is not really easy to do in Postgres, because in order to do that, you would have to establish bidirectional logical replication. And that is a whole other can of worms that you don't want to open, because there's all these considerations like conflict handling and keeping track of replication origins and things like that you have to worry about then. And it might increase the complexity of what's a really simple operation many times and actually discourage you from going ahead with it. So in the end, you have to consider what the impact would be of rolling back. Do you have the option of, let's say, losing the few rows of data that you ingested after the cutover when you decide to switch back? Or is it worth investing in all this infrastructure, like a replica of the database that needs to be kept in sync and also replicating back to the original database, right? There's all this complexity you have to consider.